Section 4.3, Binomial Distribution Probabilities. So basically there are four parts here that define what's called up here a binomial experiment. So in the past, like chapter 3 has defined different types of experiments that involve probabilities and random variables. But this is a special case here, which these components will define what's called binomial. First part, the BI in binomial, like bicentennial or bicycle, meaning two, that there's two possible outcomes defined here that we'll emphasize on, and the P stands for success, what we'll deem as a success, and Q is the complement of that, or the failure. So that's what they mean by two in binomial. Fixed number trials N denotes like the in statistics, the sample size, kind of like the same concept, like 5 people, 10 cans are chosen, things like that. They have to be independent in that case, that as you go from one case to another, that the probabilities don't change, and that's the definition of independent probabilities. I don't cover that a lot, it's particularly when I talk about conditional probabilities. So nonetheless, we'll go over that here, that we'll talk about independence. And down here at the bottom, the possible values for x, always going to start off with 0 and then stop it in what we deem by a success, or in this case 0 would mean that there's no successes, but stop all the way up to n. So we'll kind of outline those parts there for binomial distribution. For example, moving right along here, let's go to this problem here, dealing with a multiple choice question. So here it kind of outlines that we'd have 4 possible answers, A, B, C, or D, and 2 possible outcomes, either it's right or wrong for each question. Suppose that there are 6 multiple choice questions. Joe guesses on each with no pattern, determine if that is a binomial experiment. So kind of outlining here, say that you have this quiz. What month does this book start out in? Again, I have no idea what this book is, I'm just guessing. What city does this book start out in? Then I have no idea, I'm just guessing. So imagine you kind of had a quiz that had 6 questions you had no idea about. Fixed number trials, so yes, there are 6 questions, and that being the case, are there possible outcomes for each one? In this case, we note that a possible outcome would be a correct statement or incorrect. Either you get for each one right or wrong. And the probability of success that you do get it right is that 1 out of 4, and that's what they mean by having choices, 4 possible choices there, A through D. 1 is right and the other 3 are incorrect choices for each question. Notice that if you add both of those probabilities, that will always be equal to 1 or 100%. And are they independent? They are. That's because Joe is guessing. He has no prior knowledge. Otherwise, if Joe did do something like study, then the probabilities would change, thus increasing his chances of success on any one question. So suppose he didn't study, then therefore these probabilities are the same for each question. And then the possible values there for x, x being 0, that he got none of them right, or 6 there being that he got all 6 correct. That could happen. So if you have questions there on a multiple choice and you had no prior knowledge, of course case studying something looks like this, that would be a classic example of binomial experiment, because you get either you get it right or wrong for each question. There's no partial credit. Okay, this next one here is looking at a statement. 65% of people pass the driver's exam first try. A group of 50 individuals who have taken the driver's exam is randomly selected. Give the reasons why this is a binomial problem. So in this case here, there are 50 individuals. For each one of those individuals, either you passed or you didn't pass the test. And so based upon some sort of quota statistic here, we know that we've got this, trying to highlight this 65% here. That is passing, and then the complement of that is 35%. Again, adding to 100% for each individual. Either they passed or they didn't pass. Are they independent? Well, it stated up there that they have already taken the test, and assuming that they did not cheat, there was no influence of any of that. So therefore, the 65 to 35% would not vary between each individual. And the possible values for x here, 0 through n. It could be the case that if x is 0, that no one passed the test, the driver's exam. Up to 50 could be that all 50 individuals sampled did pass. So either you did or you didn't, black and white that way, binomial. This would be an example of a binomial experiment. And this last one here, a lacrosse team is selected. Selecting a cap, and the names of the seniors are put on and into a hat, and the first three are drawn will be the captains. The names are not placed once it's drawn, so that's without replacement. You want to see if they all play the same position. State whether binomial or not. So n would be the total number of seniors in this case. Success, I guess, would be selected captain or not selected captain. However, the probabilities associated with that are definitely different. Your probabilities of getting to be a captain and not a captain vary because they're without replacement. So once the name is picked and drawn on the team, it is without replacement. So the probabilities do change over time as the names are picked from the hat. And then down here, does it look like X will be is not well defined. So very vague on that. Even dealing with seniors, so this one's out as far as this goes. This would not count. You can definitely find probabilities with each one of these, but this would not fit a binomial experiment. So as we get in these, we're going to start looking at a calculator in a specific situation that outlines specifically what constitutes a binomial. If it does, and it is a binomial experiment, therefore you can use calculators to quickly find these probabilities without having to do much work. So that would be an advantage if we do know we are dealing with a binomial experiment.